Let's talk about nuclear fission, a process that's often referred to as splitting the atom. So in nuclear fission, you have an atom that splits into two or more smaller pieces. This process of splitting can release a tremendous amount of energy. And nuclear fission provides the energy for things like nuclear submarines, nuclear power plants, and even nuclear bombs. Let's look at a big picture of what's going on in nuclear fission. So in nuclear fission, we start with an unhappy, also known as unstable atom. This atom is so unhappy that it splits into two smaller atoms that are more stable than the first one. Whenever we go from something that is unstable to stuff that is more stable, it causes energy to be released. So that's where the energy from nuclear fission comes from the transition from unhappy or unstable to happy and stable. So that's the big picture. Now let's look at some more details. So in nuclear fission, we can start with an atom like uranium-235. And uranium-235, it's pretty unstable. It's a pretty unhappy atom. To make this split, we try to aggravate it. And here's what we do. We take a neutron and we slam this neutron into the atom. I'm just showing the nucleus here. These are the protons and neutrons in red and blue. I'm not drawing the electrons because they're not really important for what we're doing here. So anyway, this uranium-235 atom gets this neutron and it holds on to it, which turns it into uranium-236 because it has one more neutron. Uranium-236 is super unstable. It is way more unstable than uranium-235 is. And in fact, it's so unstable, it's so unhappy, that it splits into two smaller atoms. Here are the nuclei right here. One of them is krypton-92, and the other is barium-141. Both krypton and barium are way more stable. They're both way more stable than either of these atoms that we started with. So we're going from unstable to stable, so energy can be released. Now this actually isn't the only thing that gets made. Also in the process, 3 neutrons, here they are right here, 3 neutrons also get created. So here's sort of a picture view of what's happening. Here's how we'd write this in a nuclear equation. We start with uranium-235, add a neutron to it, and get uranium-236, and that then splits into barium, krypton, and 3 neutrons. Sometimes when people are writing the equation for fission, they won't put this in, they'll leave it out, and that's because 236 doesn't stick around for a long time. It's so unstable, it wants to split apart right away. Now, it turns out that krypton and barium aren't the only atoms that the uranium-236 can split into. When it splits, sometimes it can also form rubidium and cesium. It's just splitting a different way to create these. Or it can split another different way and create strontium here, strontium and xenon. This isn't super important. I'm just mentioning it to let you know that krypton and barium aren't the only atoms that can be produced by nuclear fission. So if you see one of these other reactions, it's not wrong. It's just showing a different way that uranium-236 can split. Now, a lot of times, people wonder if uranium is the only element that's so unhappy that it can split. And no, it's not. Actually, any element, I should say most elements, with atomic numbers from 90 to 100 are unstable enough that you can provoke them in one way or another, maybe by adding a couple neutrons, and that will make them split. If something can split, we call it fissile. So most of the atoms with atomic numbers from 90 to 100 are what we call fissile. So anyway, a lot of times we can use nuclear fission to produce energy. But if all we're doing is splitting just one uranium atom, it's not going to produce a whole lot of energy, all right? This, if we want to make a whole bunch of energy, this is where these 3 neutrons are going to come in. Check this out. So let's look at the role of these 3 neutrons. I'm going to use a circle to represent an atom of uranium-235 here, and here's a neutron coming at it. This guy's going to split, and it's going to release 3 neutrons. So here are the neutrons coming out of this thing, okay? Now, each one of these neutrons can bang into and cause another uranium atom to split, okay? So now this one uranium atom created 3 neutrons that can split 3 new atoms. Each one of these makes 3 neutrons, okay? Here are the arrows for the neutrons coming out. And each one of these neutrons can split a new uranium atom. So I'm not going to draw this all the way, but you can see that very quickly we can be splitting tons and tons of atoms. Now, each time we split one of these atoms, it releases a little bit of energy. But when we split a whole ton of them, that's when we start releasing tremendous amounts of energy, like nuclear bomb amounts of energy, okay? And the whole point of it is that what's going on here is what we call a chain reaction. Split this, causes this to split, which causes this to split. This is kind of like how rumors spread, right? It's like if you tell somebody a secret, but then they tell 2 people, and each one of those tells another 2, and they all tell another 2, pretty soon everybody you know, everyone in your school knows a rumor. So that's exactly what's going on here. So this chain reaction can cause a tremendous amount of energy to be released very quickly. In just a second, a chain reaction can get out of hand and create a huge explosion. But if you're using nuclear fission for something like a nuclear power plant or a nuclear submarine, you don't want to have a huge amount of energy being released. And so there are a few ways that you can control the amount of energy that's released. One of them is to just use a smaller amount of uranium. Here's what I mean. Here's a uranium atom, and here's the neutron heading towards it. It's releasing 3 neutrons, but if there's not a lot of uranium in here, maybe there'll be only one neutron, maybe there'll only be 1 uranium atom for this neutron to hit, okay? And then this guy will release 3 neutrons, and only one of these 3 neutrons will hit another uranium atom. So that's one way that you can keep this reaction under control so that it doesn't get out of hand. Another is that you can use various compounds that will soak up these neutrons so that they won't be able to hit the other uranium atoms. So it's like these wouldn't even be able to hit the uranium atom because they'd be soaked up. So anyway, that is how nuclear fission creates energy by taking an unstable atom and splitting into 2 more stable atoms. And then these neutrons that get released in the process can go and split other atoms, causing a chain reaction.